Okay, in this video, we're going to talk about dilations. So now we're talking about multiplying by a whole number or a fraction. And then the question is it a vertical dilation or a horizontal dilation? And so it depends on where the number is. If the number is on the outside, it's going to affect your y's, which means it's vertical. If the number's on the inside of the parentheses or absolute value or square root, it's going to affect your x values horizontally, and it's going to be opposite. When it's inside, it's opposite. So let's look at a vertical dilation first. So a vertical dilation is your y values. And so the way that's going to look is it's going to be on the outside, right? So let's say we have 2x squared. So this 2 is on the outside. So that's an a value. What that means is it's going to be a vertical dilation of 2. So we're going to take the y values and multiply them by 2. And so my new y values are going to be 8, 2, 0, 2, 8. My x values stay the same. So when I graph this, the x values are the same, and now I'm going to use the pink y values. So I'm going to have -2 all the way up to 8 now. Which is pretty high. It's way up here. Then I'm going to have -1, 2. I'm still going to have 0, 0. Then I'm going to have 1, 2. And then I'm going to have 2, 8. And so I still get the symmetrical parabola. And so the question is, how did it change from the parent function? And so remember, the parent function was the original purple ones. So we could regraph that and see it if we want. So we had -2, 4. We had -1, 1, 0, 0. We had 1, 1, and we had 2, 4. So from the parent function, which is the purple, to the dilation, which is the pink, what happened? It got skinnier, right? Or because it was vertical, because it was the y values, we could say it was a vertical stretch, right? So a vertical stretch. The y values got bigger, so my graph kind of got longer, right? Not by a lot. You'll see that it's not too bad, and that's because 2 is not a huge number. If we did 4 or 5 or 6, it's going to just keep getting skinnier and skinnier, which means it's a longer stretch, a vertical stretch. So in words, verbally, there's a few ways we can say this. We can say that it had a vertical stretch with a scale factor of 2, or we could say it had a vertical dilation with a scale factor of 2. Okay, so if you want to use the word dilation, you can. All right, so let's look at horizontal next. So that was vertical. Okay, so I'm going to keep the purple graph right here because that one's the original. I'm just going to erase the pink. So now if we talk about horizontal, horizontal is affecting your x values. When it affects your x value, it's going to be inside a parenthesis, or inside the square root, or inside the absolute value. And so when it's inside, it's opposite, okay? So we're going to look at this and we're going to say, okay, an example. Let's say we have something like this. Switch over. So we have 1/3 x squared. But it is inside the parenthesis. It's not outside. So because it's inside, it's going to be horizontal. And anytime it's inside, it's actually opposite or reciprocal. So because this says 1/3, okay, we're actually going to switch it. And so the reciprocal of 1/3, if I flip these, is 3/1, or just 3. So this is going to have a dilation where I'm multiplying my x values by 3. Okay? So again, when it's horizontal, when we're talking about the x values, we're doing the opposite. So the reciprocal in this case was 3. So I'm going to now take all these x values and multiply them by 3. And that's going to be my dilation. Okay? So if I multiply this by 3, and this by 3, and this by 3, and this by 3, and this by 3, we're going to do all of them. Okay? So we get -2 times 3 gives me a -6. 3 times -1 gives me a -3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 2 is 6. So these are my new x values. The y values stayed the same. So let's graph. So x is now -6. 1, 2, 3, 4, 5, 6. We're going to go all the way to +6. And then over here, we're only going up to 4. Okay, so -6, 4. So -6, +4. -3, 1. -3, 1. 0, 0. 3, 1. And then 6, 4. Okay? And so if I compare that, again, to the original parent function, that's what I'm doing. I'm comparing this. So if I did the original, I'm just going to do it really fast again. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So my original is right here in purple. That's my parent function. So what happened? It got way wider. And why? Well, because I took my x values, right, my x values, and I multiplied them by 3. And so that stretched it horizontally. Okay? So anytime you have a fraction, remember the fraction is doing opposite and it's stretching it horizontally. And so that made it wider. So we had discussed when this is a fraction, this gets wider. And the reason is because it's opposite, and so I multiplied all my x values by 3 in this case. Okay? So all these x values enlarged, but the y value stayed the same, and what that did is it made my graph wider. It's like taking my parabola and pulling it this way, is what I did, okay? How do I say it verbally? Well, there's a couple ways, right? We can say that it had a horizontal stretch of 3, or we can say it had a horizontal dilation with a scale factor of 3, okay? And so this 3 is important because if you would have done it by 1/3, you'd have gotten a skinnier one, okay? And so again, when it's inside, it's opposite. The x values, the horizontal, is opposite operation. The vertical is on the outside, and it's as is, okay? And then dilations are a multiplication of either a fraction or a whole number. Translations are an addition or a subtraction. Okay, so now the next video, we're going to combine multiple transformations into one.